let's go through our factoring worksheet, our advanced factoring worksheet. So first thing we do when we factor is always look for the monomal we can pull out. So look at the first two. What do they have in common? They both have an x. So I can factor out an x. Remember, all factoring is dividing. So if you're not sure, you just like pull out the x and divide everything by x. So 6x divided by x is just 6, the x's cancel. 13x cubed divided by x is 13x squared. And there we go, that's all you can do. Done. With the next one. They have a couple things in common. They actually both have a 3. You can pull out a 3, divide them both by 3. And they both have a t, but what's the biggest number you can pull out? A 2. Right, that's a 3, you can't pull a 3 out of this guy. So t, 3t squared. Again, if you're not sure what's left over, just divide. 3 divided by 3 is 1. T cubed divided by t squared, they all cancel except for 1. So t. 9t squared, 3t squared. 9 divided by 3 is 3. T's cancel out. So, over here, same idea. What do they all have in common? I could divide 24, 8, and 28 all by 4. Biggest thing can't cancel out. And they all have an a. So 4, and the biggest a I can pull out, or the smallest I can pull out, no biggest, is 2. Biggest I pull out from all of them is 2. I can't pull out a 6 from all of them, I can pull a 2 out from all of them. Again, all we do is divide. 24 divided by 4 is 6. A squared divided by a squared is nothing. Then negative 8 divided by 4 is 2. A4 divided by A2, you just subtract 8 squared. 28 divided by 4 is 7. I had 6 a's, I took away 2 a's, so there's only 4 a's left. Right? I had 2 a's, took away 2 a's, so none left. So there we go. Over here, next, a little more complicated. What do these all have in common? Well, they actually all have an n minus 3. Every single one has an n minus 3. So pull that out. What's left over? Well, that's gone, that's gone, that's gone. What's left over is m squared plus m. And don't forget this guy. Remember, all we're really doing is dividing. N minus 3 divided n minus 3 is not 0. It's actually a 1. You can always do that. Like, that's a 1 now. You pull it out. It's a minus 1. That's our answer. Over here, they have in common. They both have the y minus 3. See? And pull these guys out. That's gone to 1 now. Gone to 1 now. What's left over? X squared minus 9y squared. And that's the answer. So now this factoring completed. This is a different type of factoring. This is the difference of two squares. Right? That's this guy. A squared minus b squared. It's a very special type of factoring. When you see that, you can make it a minus b and a plus b. Base square root of each one. So that's a squared and that's a squared. I mean, if you want, you can write like this to see a little better. Right? So it's going to be x minus 6 and x plus 6. Next one, right? So same way, they're both squares. What's the square root of 4x squared? You got to square both of them. So it's 2x minus square root of 81 is 9. And then 2x plus 9. Over here, that's actually not a square. 2 is not a square. So you're like, I'm done? Can't do it? No, what's the first thing we always check? Could I factor anything out they have in common? These actually both have a 2 in common. Right? Factor out a 2. What's left over? X squared minus 9. Remember, factoring is just dividing. 2x squared divided by 2 is x squared. 18 divided by 2 is 9. And then now this is a perfect square. I could square root that, square root that. 2 from right there. X minus 3, x plus 3. 28 squared minus 45. These are both not squares, but again, do they have anything in common? They both have a 5 in common. So pull that out first, and you're left with 4a squared minus 9. And this is a square, right? That's 2a, that's 3. So 5, 2a minus 3, 2a plus 3. This one, they actually happen to both be squares. Square root of that's 2x, square root of that's 7y. So 2x plus 7. And I'm wrong. That's a plus sign in the middle. Okay, I got ahead of myself. That plus sign can't factor, right? The difference of two squares is the difference of two squares. It has to be a minus sign. Something was up, so not possible. So you can't factor it, so a nice way to say it's called prime. Right? It's just like you think about number 3, you can't factor it, so prime. The 9x squared minus 1, now these are both square roots. So that's 3x, so 3x minus 1, 3x plus 1. There we go. Factor completely. Now these are factors of the number front. So the way I showed in the lecture video was I like to multiply the first term and last term with the number front. So I get negative 18n squared. And then we try to do like normal. Like, okay, what are two things that multiply to get 18? But when you add them, you get 3. Now it's a negative 18, so they be different signs. So in that case, it's going to be, what's that, 6 and 3? Right? It could be 6n minus 3n, or it could be 3n minus 6n. When I do this, I like to keep the negative in the middle. Actually, I like to keep the negative in the front, but I'll do it. It works either way. Now, which one of these gets me a positive 3n? That would be this guy. Right, when I add these, I get a positive 3n. And notice you multiply n times n, you get n squared. Negative 3 times 6 is negative 18. So that's what's going to work. What we do here is this. You sub it in for the middle term. That 3n is gone. It's going to be 6n minus 3n. So those are equivalent. So let me rewrite it. So now I get 2n squared plus 6n minus 3n plus minus 9. Right? So this guy turned into this guy. Instead of 3n, I have a 6n minus 3n. Now all I do is my favorite type of factoring, which is factor by grouping. So we're going to group these two together and these two together. Now in these two, what do they have in common? A 2 and an n. Remember, factoring is just dividing. 2n divided by 2 is 1. You add n squared, now you took an n away, so there's only 1 left. Plus 6 divided by 2 is 3. You add an n, you took an n away, so there's none there. Now when we get to this part, it's a very important concept. You always bring down the middle sign. So this is a negative, you have to bring that down. So there's a negative there. Now we'll do 3 and 9. 3 and 9 have in common a 3. Now don't forget, factoring is dividing. So negative 3n divided by negative 3 is a positive 1n. Negative 9 divided by negative 3, because what I have down here, it's a positive 3. So that's why the sign flips. Because right, you're just dividing by negative 3 because you brought the sign down. Now look what happens. What do these have in common? N plus 3. So pull that out. That's a 1 now. And what's left over? 2n minus 3. And we have factored successfully. So that's the way. That's what I like to do it. I'm going to get to this one. 2v squared plus 11v plus 5. So same idea. 2v times 5. That's 10v squared. Right, what are two things that multiply to get 10 but add to get 11? Ooh, that's easy. 10 and 1. Right, 10 times 1 is 10. 10 plus 1 is 11. So again, we're going to sub that in for the middle there. So 11v to be gone. It's now 2v squared plus 10v plus 1v plus 5. Those are v's. My writing sucks. Okay, then we factor by grouping. These two have a 2v in common. So again, all we're doing is dividing. So 2 divided by 2 is 1. V, you had 2 v's, now you took 1 away, so there's only 1 left. 10 v's, that's a v. 10v divided by 2v is 5. Always bring down the middle sign, so it holds true here. Now look at this one. 1v plus 5. Do they have anything in common? They actually don't. So here's the thing. Here's a key thing, right? If you can't factor anything out, you can always factor out a 1. So there has to be something here, so you make it a 1. So if they have nothing else in common, pull out a 1. Very, very, very important. So if they have nothing in common, pull out a 1. Now what happens? Well, these two things match, so you pull those out. V plus 5. These are gone. They're 1s now. And look what's left over. 2v plus 1. Factored. I'm going to skip that. We'll do that next lesson. So over here, now we get to the even more advanced factoring ones. So this first one here, that looks disgusting, right? I don't want to multiply 9k times 21. That's an ugly number. So don't forget the first step. Do they have anything in common first? Can you factor out a monomial? And you can. You can pull out 3 out of all these. So you factor by 3, pull a 3 out. Remember, all you're doing is dividing. So 9k squared divided by 3 is 3k squared. 66 divided by 3 is 22. And 21 divided by 3 is 7. I should have wrote that bigger, but you get, oh, that looks ugly. Let me write that bigger. So 3k squared plus 22k plus 7. There we go. Right, so now it's going to factor just like I normally would. Right, I multiply the 3k squared and the 7 because there's a number in front. So multiply these two and I get 21k squared. Well, two things multiply to get 21, but add to get 22. Some of the easiest ones, 21 and 1. Now sub it in for the middle. So we have this. Put the 3 out here. Have 3k squared plus 21k plus k plus 7. Right? The 22 is gone and it's replaced by 21 plus 1. Now we factor by grouping, my favorite type of factoring. The first two have a 3 in common, a 3k in common actually. And the k plus 7. Don't forget this is all, there's a 3 on the outside. Always bring that middle sign, the plus. K plus 7, they have nothing in common, so we put the 1 on the outside like we just did. And that's a k plus 7. Like that. And then look what happens. These guys match. So k plus 7. What's left over? 3k plus 1. Don't forget there's a 3 on the outside. There you go. It's a little sloppier than I wanted to, but you got the right answer. The next one, that one looks like I've seen, like 7a squared plus 53 plus, I don't want to multiply 7 times 28, but do they have any common? They actually do. They all divide by 7. So you get a squared. They do not divide by 7. That's a 53, not a 63. My mistake. So I guess I gotta multiply by 7 times 28. I don't want to do that. I could, it does work. That's a mess. So there's other ways of doing this. A lot of people do the guess and check method, which is you do the front. It could be either 7 or 1, and you do the back. That could be 4 and 7. It could also be 2 and 14. Right? And when you do the guess and check method is this. I mean, good, you could do it 7 times 28. It works. It's a lot of multiplication. So you can do it this way, which is guess and check. So when people do it fast, they kind of do this in their head. So they're guessing, checking, they're going, okay, the front has to be between 1 and 7. The back has to be between 4 and 7. Or it could be like other things, but most likely 4 and 7. It could be 2 and 14, it could be 128 still. But most likely it's probably going to be 4 and 7. So what you do is, okay, what if I multiply these out? I get 28, and I get 7. So I get 35. That's no good. I want 53. So what if we switch it? What if I made 7 times go by 7? That'd be 49. And I made 1 go by 4. That'd be 4. I would get 53. That's the one. So how do I write this out now? Well, I know here's my front. Here's the back. So front doesn't matter. We'll put 7 someplace, 7a, and then 1a. The back is where it matters. Now, 7 times 7 was 53. So you actually can't put it here, which a lot of people tend to do. Right? You have to multiply them. How do you multiply? You multiply front times back. These two don't get multiplied together. So you have to put the 7 here. So it gets multiplied by that 7. And then means you got to put the 4 over here. So it gets multiplied by that 7. So my answer is going to be 7a plus 4, a plus 7. Now again, you could have done it, multiply 7 times 28. It does get really big, but it does work. But I just want to show you an alternate route of doing it. So that's when you see people do it like guess and check, that's what they're talking about. They do the possibilities for front, possibilities for the back. They multiply across, see if it works. If it doesn't, they multiply the other two, see if that works. If this wouldn't have worked, I would have to try 2 and 14. If that didn't work, I would have to try 1 and 28. Let's move on to this one. It looks big again. I might have to do the guess and check, but these do actually divide by 3. So 5n squared minus 9n minus 2. Again, if you want, you can do guess and check here. It still works. But I'm going to try doing it the other way just one more time. Right? Let's multiply these together. You get a negative 10n squared. And these two things are multiplied, I get negative 10, but I have to get negative 9. That would be 10 and 1. Negative 10n and 1n. Like that. Right, so when I multiply, I get negative 10. When I add, you get negative 9. So again, I'm going to plug that in for the middle. I'm going to leave the 3 out for now so it's not as cluttered. I'll put it back at the end. So you get that. And then, first two, last two, right? These two have a 5 in common, a 5n in common, so factor of 5n, n minus 2. Always bring the middle sign. These have nothing in common, so pull out a 1, n minus 2. These match, so n minus 2, 5n plus 1. Don't forget, there's a 3 in front. It's like that. Over here, 5zw to the 4th minus 405z. Same idea, like that looks, so this looks like the difference in squares. There's only two things. So if it's only two things, you have two choices. Either factor what they have in common, or it's the difference in two squares. So it might be a difference in two squares. It is a negative. It is a difference. But first, let's factor what they have in common. They both have a 5z. So let's pull that out. Remember, all you do when you factor it out is just divide. So if you divide this by 5z, the 5z is gone. You're left with w to the 4th. If you divide this by 5z, you get 40 divided by 5 is 8, 81. And the z is gone, so it's just like that. Now this is a difference of two squares. You're like, wait, that's not squared. It actually, you could square root. You actually take the square root of 4, you just divide it by 2. So it's w squared minus 9 and w squared plus 9. It works the same way. You're like, am I done? You're actually not, because look right here. That you can't do, it's not a difference. It's a sum. But that's a difference of two squares again. So I could go one more time. W minus 3. W plus 3. There's still w squared plus 9. And don't forget the 5z. So that's, it worked all the way out. So again, if it's an even power, you can divide it by 2 to square root it. Learn more about that later, and then keep on going down. 5n squared plus 19n plus 12. So these other things in common, I can multiply. It's actually not that bad to multiply them. You get 60n squared. And what combination gets you 60 but 19 would be 15 and 4. But since I did the guess and check method, I want to do it one more time. So I'm gonna do it here. So if I do the guess and check method, you want to do the front, you want to do the back. So you go, okay, what are my options for the front? It's 5 and 1. Only thing it could be because it's prime. 12 actually had lots of options. I could do 2 and 6. I could do 3 and 4. I could do 12 and 1. Right, actually lots of options there. You just pick one. I normally try the middle one, the one that's most like middle-ish, because I think that's generally how it works, but we'll go in order. So let's do 2 and 6 first. I want to show you one how it doesn't work. So like, how do we do this, right? So first you multiply across. So I get 10 and I get 6. Add down, I get 16. That does not equal 19, so that didn't work. So then we do the combination. What if I switch these combos? So the 1 times 2 would be 2, 5 times 6 would be 30. 32. That didn't work. So it's not 2 and 6. So let's try the next one. Let's try 3 and 4. Let me erase. So 3 and 4. Go across. I get 15. I get 4. I don't know if I get 19, which is what I want. So I don't have to try the other one. I don't have to try 20 times. 20 plus 3. 20 didn't work. So how do we set it up? So remember when we set it up? It's binomo times the binomo. Here's front, here's back. The key thing to this is that when you multiply these two and these two. So, like the front, 5 and 1, put it somewhere. 5, 1, don't forget the ends. The back, 5 has to multiply by 3. So you don't put it next to it, it has to multiply by it. So how do you multiply 5 by 3? It gets multiplied over here. This has to be 3, and it's a positive 3. And then same thing with here, 1 has to multiply by 4, so 4 has to go here. And they're all positive. So that's how I do the guess and check method. Again, it would have worked if I would have done this and just factor by grouping. Pick the method you like. This one has a 6 in there. I'm going to do the factor by grouping methods because it doesn't change at all. It's the exact same thing. This problem is exactly the same if this or like this. All you do is multiply first term, last term. Negative 24, A6. I need two things to multiply to get 24, A6, but I add to get 2, negative 24. So that should be what? 4 and 6? Negative 4a plus 6a cubed, right? How do you split up a 6? 3 and 3. And then it could be negative 6a cubed plus 4a cubed. Right, one of those is going to work. They're off by 2, but they multiply to get 24, and it is. I want a positive 2a, so that's going to be this one. And all we do is plug it in, sub it in, get rid of that 2. So it looks like this. 8a6 plus 2a is gone, sorry. Minus 4a cubed plus 6a cubed minus 3. Right, just like we've been doing. Multiply the first and last, you get 6. How do I split it? It should be a3 on either side. And then find the combination to get 224, but I have to get 2. Plug it in for that 2. That 2's gone now. keep the sides the same. Then we just factor by grouping. These have a 4a cubed in common, right? They both have a 4, and the most I can pull out is an a cubed. So again, all we're doing is dividing. 8 divided by 4 is 2. I had 6 a's, I'm taking away 3, so there's 3 left. 4 divided by 4 is 1, negative 1 actually, and you took all the a's away. Bring down the middle sign. These have a 3 in common, that's it. That's all they have in common. 6 divided by 3 is 2, a cubed. 3 divided by 3 is 1. So you get that. Hey, these match. So you get 2a minus 1 cubed. And look what's left over when we pull these out. 4a cubed plus 3. So there we go. That's the video lesson. Worksheet.